Okay, scholars, please raise your hand if you can hear me. All right, so today is part 3 of our discussion about calories. And we're going to make good use today of our understanding of heat absorption and calorimetry. So we're moving into a calorimetry lab, and that'll happen next week. So last time we had an equation, and that equation was Q equals mc delta T. Okay, that's a Q. I understand my Q's look a little bit like G's, but that's a Q. So Q stands for heat absorbed. And the unit for that is cal. Okay, C-A-L stands for calories. M stands for mass. And our unit is grams, little g. C stands for specific heat. And the units of specific heat are 1.0 cal per gram degrees Celsius. Okay? And we can all say this unit out loud. We should, okay? 1.0 cal per gram degrees Celsius. Oh, I'm so sorry. That's the 1.0. That's the unit for, that's the number for water. So the unit actually is just cal per gram degrees Celsius. We'll use the 1.0 in a minute. So cal per gram degrees Celsius, okay? So specific heat's unit is cal per gram degrees Celsius. Everybody says it on the count of 3. 1, 2, 3. Cal per gram degree Celsius. 1, 2, 3.
Cal per gram degree Celsius.
Good. That little tiny circle up there, that symbolizes degrees. Okay? That lets you know we have degrees Celsius. Kelvin temperature just says K. There aren't degrees Kelvin. Why? Because Celsius is not an absolute temperature scale, whereas Kelvin is. Okay? We have degrees Celsius. We just have units Kelvin, just like we have units like grams. Okay? So delta T. Delta T stands for change in temperature. Okay, change in temperature. And the way we calculate that is we go T final minus T initial. Okay? T final minus T initial. So now we're going to go through an example problem just like the one we did last time. And here's the example. So if 22 grams of H2O, which has specific heat equals 1.0 cal per gram degree Celsius. Okay? If 22 grams of water are heated from 45 degrees Celsius to 65 degrees Celsius, how much heat does the water absorb? Question mark. Okay? So 22 grams of water, which has specific heat, 1 cal per gram degree Celsius, going from 45 Celsius to 65 Celsius. How much heat does the water absorb? All right. So what I want you to understand is that if this problem confuses you, you're not paying close attention. Doing this problem is very easy. Everybody in this room can do it. Okay? Really, really, really straightforward. All right? If we're going to be college ready, and we all are, then we have to be able to do this. So I'm going to wait just a tick while everybody updates his or her notes. And then we're going to talk about how to do this problem. Carissa?
The word after R, what is that?
Heated. 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 All right. So I know we're probably still copying down the problem, some of us. If you're still copying down the problem, I'll just tell you to hold on for a second, because you'll have more time in a minute to copy it down. Right now, I want to direct your attention to the board. So, what is the question part of this question asking? What does it say?
How much
How much
heat
heat
does
does
How
the
much
water
heat,
absorb?
right, does the water absorb? Okay, which part of this equation is the heat absorption part?
Q.
Q. So this question asks us to solve for
Q.
Q. Okay, so we're solving for Q, right? So you're solving for Q, and you say to yourself, Q equals what? Okay, so MC delta T. Do we see a bunch of plus and minus signs here?
No.
No. Do we see a bunch of division symbols here?
No.
No. What's going on here mathematically?
Multiplication.
We're multiplying, good. Okay, M times C times delta T. Well, let's find those values in the problem. What's the mass of water that we're dealing with?
22 grams.
Right, 22 grams. What's the specific heat of water we're dealing with?
1 calorie per
Oh.
gram Celsius.
Yeah,
Degree
1
Celsius.
calorie per gram degree Celsius, good. And then delta T, change in temperature. Now you can plug these in and you can do 65 final minus 45 initial gives a number. You can just look at it and think, how much did the temperature change from 45 to 65? How many degrees was the change? Huh? Say it louder. The change in temperature of water was on the count of 3. 1, 2, 3. 20 degrees Celsius, good. So we just have to plug these numbers in and we get an answer, yeah?
Yeah.
Take 30 seconds, do that, go. Solve the problem.
Would it just be 20?
Okay, who can take us through the solution of this problem? Paolo, what'd you get? Did you get the answer? You think, okay. Get us started, all right? So, what's the first thing that we plug in? MC delta T, right? What do we do?
22
22 what?
grams.
Good. The mass is 22 grams. Okay. We're going to multiply that by something. Kevin, what do we multiply the 22 grams by?
1 over 22, or
Oh.
the
1 over
Can't-
what? Read the
One.
unit.
1 calorie over 22 grams degrees Celsius.
1 calorie over, is there a 22 in that unit?
Oh, no.
No, 1 calorie over
G
times,
degrees Celsius.
yeah, 1 calorie per gram degree Celsius. So don't get confused by the fact that there are 22 grams somewhere else and there's a G here. You just write the unit itself, okay? So 1.0 cal per gram degrees Celsius, okay? You write the value that you do have, right? So the unit is calorie per gram degree Celsius, and it's times 1. and your 22 is something separate. Your 22 grams are separate, right? Then what's the last thing we have to multiply?
20 degrees Celsius.
Good, delta T, which is, Delilah?
20 degrees Celsius.
20 degrees Celsius, good. Okay, and now look at the unit, scholars. Grams times 1 over grams, what happened to the grams? Cancel out. Celsius degrees times 1 over Celsius degrees, what happens to the unit? Cancels out, good. So those cancel. Boom. What's the unit we're left with? Okay, calories. And were we looking for calories?
It's Q.
Is Q measured in calories?
Yes.
Yes. Okay.
It cancels out Q.
Good. No, it doesn't cancel out. It's left. So that equals, correct me if I'm wrong, but 440 calories. Okay? Is that what we got, Paula? Good job. All right. So that's problem 1. Here's the last problem for the day. We should all be able to do this problem, but I'll make my way around to check in. So watch. This one's pretty cool. So if 500 grams of water and specific heat equals 1.0 cal per gram degrees C, we know that, are heated from 22 degrees Celsius to 100 degrees Celsius, how much heat does the water absorb? So, 22 degrees Celsius all the way up to 100 degrees Celsius. Now, why might this be significant? So the cool thing about this problem is that if you're making coffee, you might say to yourself, well heck, I'm going to put half a liter of water, and that's 500 grams, that's half a liter of water, okay, into a tea kettle. That's about a little water bottle's worth, right? And you say to yourself, okay, I'm going to have to heat this. I'm going to have to boil it. Well, it starts out at 22 degrees Celsius, and when you boil it at 1 atmosphere pressure, like we are here at sea level, you get to 100 degrees Celsius. So this is the amount of energy that a tea kettle full of water, or that the water in a tea kettle will absorb, okay, as it goes from room temperature to boiling. All right, so go ahead and solve this problem, and take a couple minutes to do that. We'll go through it in a little bit as a class. Okay, scholars, so I'm going to check in with everybody in a little bit, but I'm going to present the solution right now for the sake of time for our lecture recording. So we have Q equals mc delta T, and our mass in this situation is how many grams?
500.
500, right? So 500 grams times 1.0 cal per gram degree Celsius times a change of temperature of 78 degrees Celsius. Grams and degrees Celsius cancel out, and we get 39,000 calories. Now what's crazy about that is, that's only about 5 potato chips worth of heat energy, right? Because when humans eat calories, they don't eat these little calories, okay? That's not the calorie measurement we use on our food. We eat calories with a big C, which means kilocalories, which means 1,000 calories. So it takes 5 potato chips to boil your tea kettle full of water. Okay, I'm gonna come around and check in.
Those 5 potato chips.